I need your attention up here, please. Yesterday, we had this I can statement, finding values of trig functions based on the unit circle. So remember, when you have a point, if a problem tells you that a point P or a given point is actually on the unit circle, any point on the unit circle with coordinates x, y. Anyone remember between sine and cosine what the x coordinate is equal to? Cosine, yep. So x is the cosine of the angle theta, and then the y coordinate is sine of theta. So any point that's on the unit circle, those coordinates, the x coordinate is cosine of the angle, y coordinate is sine of the angle. So that you need to know and to understand. We had used that in some problems yesterday. So then there's, I've referenced throughout this chapter, and it's even been brought up in different cases, the special angles of 30 degrees, 45 degrees, 60 degrees from those special right triangles that you cover in geometry. Those angles are worked with the most often in trig. So those angles are also part of the unit circle. So we're going to be filling this in. We will be using these special right triangles. You'll see how we'll use those. And what I'm going to start with is, I know there's a lot of different blanks on here, so you'll notice at each, like all of these lines are representing different angle measures, and there's two different blanks at each angle measure. There's a blank for you to put the degree measure, and then the blank next to it is where you would put the radian measure. So we're just going to focus on the degree measures first, and then if we have time, because I want to make sure I leave enough time for your homework quiz, we'll then fill in all of the radian measures after we fill in the degree measures and all of the coordinates. But if we don't have time, we can always fill that in later. I just want you to have a basic understanding of the unit circle. So starting out, I know this angle here is an angle of 0 degrees. And then I'm going to fill in the quadrantal angles first. So this is 0. I know this angle is 90. Halfway around the circle is 180. 3/4 of the way around is 270. And then all the way around back to 0 is 360. So there are blanks above it and then below it to represent it as 0 and 360. Okay, and I'm also going to right away fill in those coordinates. What is the radius of the unit circle? R, but what if it's the unit circle specifically from yesterday? Do you remember what the radius is for the unit circle specifically? What would you guess would be the nicest radius?
1.
1, yes. So unit circle has a radius of 1. Maybe you want to just make that as a note. Radius equals 1 on the unit circle. Okay, so that means if the center is at 0, 0 and the radius is 1, this point then at 0 degrees and at 360 has the coordinates 1, 0. Okay, that should make sense. You would go over the length of the radius, which is 1. That would be your x coordinate. You're not going up or down. Your y coordinate is 0. What this means, though, is that, again, going back to this notion here, the x coordinate is cosine of the angle, the y coordinate is sine of the angle. That means cosine of 0 degrees is equal to 1. If you typed in cosine of 0 into your calculator, you would get 1. And then sine of 0 is 0. You could also type that in and just double check. But that's y. When you type that in your calculator and get that, that would be y. that would also be cosine of 360, sine of 360, because it's that coterminal angle. So all of these ordered pairs, that's what they're representing. Yes, it's an x and a y coordinate, but it's cosine of that angle and sine of that angle. So then going up to 90 degrees, anyone, if this had coordinates 1, 0, what would the coordinates at 90 degrees be? 0, 1. Yep. Okay, so I'm not going to write this by every one, but this means cosine of 90 degrees is 0, sine of 90 degrees is 1. At 180, what would those coordinates be? Negative 1, 0. So cosine of 180 degrees is negative 1. Sine of 180 degrees is 0. And then at 270, 0, negative 1. Cosine of 270 is 0. Sine of 270 is negative 1. And then we're back to 360. Okay, so then these three angles that are given in the first quadrant, those are your special angles. So this first one is an angle of 30 degrees. The middle one is an angle of 45 degrees. The third one is an angle measure of 60. And we are going to find what these coordinates are as well. And so I want you to think back. I'm not going to draw it on here because I know there's already going to be a lot put on the unit circle, but think back to what we did in 12.3, and then we also talked about this yesterday. If this angle, when I say this is 30 degrees, the angle would be right here. That's your angle measure between that terminal side and the x-axis. So if I drew a line down from that point, I could create a right triangle. And because this is 30 degrees, it would create a 30, 60, 90 triangle, which would look like this. And then because it's a special right triangle, I can fill in or find these coordinates knowing that the x-coordinate is going to be cosine of 30 degrees. I can find that from the right triangle. Oops. Not sure why that just shut off on me.